How's everyone doing today? Good to see you in the chat. Good to see Lucy and Jack and everyone here. We got a 25 question Kahoot coming up. Now, what I want to say is this. You are doing randomized. Good to see you. We have a lot of time to review right now. And what you want to do, thank you, Jack, right there. You guys are cracking me up. Really great time. Check out the festival going on right now on HSS, the Asian Festival, or International Festival. International. I got some ramen. Oh, dude, I got some Shin ramen. Woo! Check it out. Good stuff right here. Good stuff. So check it out on HSS Lawn right now. They've got a lot of shows. I had to leave before they were going to do a dance routine. I was going to check it out. I was like, I got to get over here. I was like, oh, it's not starting. It was all right. They're getting ready. They're getting prepped. But check it out. HSS right after this. If anyone knows what time it's going on till, drop that time in the chat. But always check out those events. Really great stuff going on here at UT. Lots of fun. Lots of cool stuff. But has anyone checked it out yet? Did anyone go by this morning? Or is anyone part of it? But love seeing what's going on at UT. So we have review 2 posted right now. And I don't want you, I'm probably going to send a message to my students later. I want you, and here's my advice. Let me go put advice for the test before we get started here on the Kahoot, because we're having people rolling in. Advice for the test. Let's go take a look at review 2. Who's clicked this in the chat? I'm going to throw some 5,000 points here in a second, but who has clicked review 2? Who's done it? Who's with me on that? Let's go to the main screen. Okay, man, check it out. It's happening right now on HSS. A lot of groups out there, all different groups from all different areas around the world. Really cool. You're so morbed right there. I like it. But go check it out right there, Cayman. It's really awesome. Like, and I got to see some K-pop. I got to try a Panyan. Oh, I'm probably mispronouncing it. I'm gonna show you what I tried. This looks like it. No, it's not. It's like a Panyan pancake or something like that. Korean green pancakes, I think it is. This looks about. It was so good. It was so good. If someone knows the exact name of it, please drop that in there. But it's made from like a leaf, they said, and tasted so good, so good. It was it was a very sweet pancake, not like too sweet, but imagine a I adore it, man. If you they put a little powdered sugar on top of it too. It starts with a P. It's the name of the leaf. I should have wrote it down because I want to have it again. So with that said, let's talk about the test. I'm going to re-timestamp this now that I've had my munchies out of the way. Okay. So here we are on the review page. Exam 2 is our priority today. What I want you to realize is this. The speedrun videos, I really love them because the speedrun videos, if you look at the length of them, they're only like 15 to 20 minutes max. Now, I go through the full lecture and explain everything, but you gotta morb in and go to the SI sessions today. Drop them in the chat if you want. But take time and review and focus in during these speed runs. You can see chapter 8 is even shorter. It has things like extrapolation, does the plot thicken. You can see sample surveys, a lot of definitions here where we go through convenience sampling, systematic sampling, cluster sampling, all those things, stratified. A lot of people get stratified and cluster confused. But I go through and give you examples, and I even write down the notes right here. So yeah, drop the SI. I think the SIs have it on their board too. But I give definitions for each one of these where it's like cluster sampling, and I walk through it right here. So I make sure you kind of see what stratified sampling is and cluster sampling is. So you can see acknowledging a difference, taking your sample proportionally with respect to that difference, multi-stage examples, all these different things right here. We're not doing conference roles. No conference roles on the test. Good question, Peyton. That will be the very next thing we start. And one of the speedrun videos kind of converges into that. It's because of the way the book got resplit up. So check this out right here. Check out the speedrun videos. Also, you can see test question videos right here. I think I put this one on here, the difference between the sampling distributions. This is like a full lecture. I put it on here because it was a pretty good full lecture of me going through everything and explaining the difference between the sampling distributions. And you can see different probability questions right here. Like, what is the probability you get a certain amount of coin flips? So these questions, I try to make them as easy to understand as possible. The probability of like lightning striking or the Knicks winning, things like that. What does it mean for things to be disjoint? We haven't done margin of error. Those are for conference roles, chapter 13. Good question, Charlie, right there. So If you're wondering what questions will be on the test, what should you click on to understand what material should be on the test? So if you're wondering what exactly is on the test, you might have to calculate z-score. So if you're wondering what material will be on the test, where should you go? The topics, right here, the topics. If you go down towards the end of this, you should see we should have calculating like a difference right here and using the 68, 95, 99.7 rule to figure out if something is unusual. And the formula sheet also gives, which we did an example like this in class, it gives a differencing formula to get a z-score right there, which is the observed proportion minus the true proportion over the standard deviation. Remember, a z-score is just a difference divided by a standard deviation. So the top of this formula is also a difference. And I'd highly suggest checking out last class lecture. We did some big examples of this, figuring out if something would be unusual, looking at the distribution. Any questions about the test in general right before we start Kahooting? If I was in your shoes, what I would do is I would say, I'm going to watch 3 videos today, and I'm going to review 1 chapter or something like that. That's what I would do. I'd say like, okay, so, and I can't have music on the background. I can't be doing other things. If you know the Podomoro method, you do like 20 minutes of work, 5-minute break, 20-minute work, 5-minute break. And each 20 minutes, you switch up what you're doing. So these videos are really good for the Podomoro method. Anyone here use Podomoro? Where you do 20 minutes on task, 5 minutes off, 20 minutes on, 5 minutes off, maybe 20 minutes on, 30 minutes off, and you switch your tasks. You don't, and Cayman right there. When I started doing this, I think it really helps. And people have Podomoro timers to be like 20 minutes on task. There's a 20 minutes where I'm staying on task, focusing in, and I'm going to review this chapter. You say, I'm going to review chapter 12 and get down some of the concepts right here. I'm going to focus in on maybe how to know if things are disjoint and mutually exclusive. So how many people do we have watching right now? Let me look at MuBot, and we'll do one poll right here before we get started. We're starting the Kahoot in about 2 minutes. Okay, we have 41 people watching. That's pretty good right here. So yesterday during class, we wrote down some notes to figure out, you know what I'm going to do? I'm going to steal from our notes. Ooh. I'll be back on the screen here in 1 second. But great job, Dylan, right there. So during class, and I put this in our online notes because we take online notes. Sometimes did I not? It doesn't post it by default sometimes. I posted the link in the chat yesterday. But here is our online notes. You're going to see it in 1 second. And there you go. You should be seeing it. There's our online notes. So that's a random graphic I drew. Here's our online notes. And you can see we wrote out events, and we're testing if things are disjoint. So let's drop this in here. And then we were testing if things are mutually exclusive. So I'm going to grab that other one to test if things are mutually exclusive or independent. The SI doesn't have dates on Canvas, but I can give you their... yeah, and they should be posting it. They should send out announcements. They should be. I can message Jake also. But we'll try. I'll send an announcement about that. Remind me, Peyton, at the end. We'll send out an announcement to let people know. But they should be posting it, and they should be sending out their announcements saying, hey, we have a review tonight, so everybody knows. And they should also record a lot of times, too. So with this, I want us to focus on how is something disjoint. So this is a very important part for the test. I know we're going to Kahoot, but disjoint and independent. Now, for those people wondering about these terms and how to get them down, I've written a step-by-step way of knowing if things are disjoint or independent. Does that make sense? Yeah, thank you, Peyton. Does this make sense? These are the steps right here to test if something is disjoint. If you know how to do these steps, if you write down the steps and know them, you got it. And we'll be Kahooting in just a few moments here. So I want to test your knowledge of these steps and help you get this down, because there's questions on the test that literally give you stuff like this. And the way to test it is if A occurs, B cannot occur. And so let's do this right here. We're going to pick 2 events, and we're going to say our D, and don't put it in the chat. I want you to put these 2 things. I want you to click a button here. I want you to click the button, are D and E disjoint or not disjoint? And we'll do the thumbs up analogy too. I think that really helps. Are D and E disjoint or not disjoint? And we might do some 13 towards the end, yeah. Oh, we're doing pretty good. I think we got Well, we had 100% on the right answer for a moment. So how do you ask yourself this? I want you to hear how to ask yourself that. I want you to put it in the chat how to, because I can tell you the answer and I can tell you how to ask yourself this. But how do you ask yourself if these things are disjoint? How do you ask yourself if these things are disjoint? These are the steps right here. So go through. I know, right? It dropped, Logan. But how do we ask ourselves this? If school is out, like we say, school is out, can my car fail? And the answer is yes. And I should have had down here so you can see it. So they are, well, that's the other one. They're not disjoint, which is the same thing as not mutually exclusive. If A occurs, then can B occur. Exactly. Does that, so if there's two thumbs up, they're both occurring at this, they can both occur at the same time logically. So it was 64%, a little better than random guess. This is why I do these things here. There's a few of these on the Kahoot too, I believe too. So now we're gonna try another one. I want to get above 75%. So remember, you just ask, if this occurs, can this also occur? So let's do, and don't put the answer in the chat, but click the button. Let's do these two, B and C. So our B and C, and we're talking about like on one day in Knoxville, like today, like right now in this moment. Like in this moment occurring at the same time. In this moment in Knoxville, at this moment, outside, right here where I am at right now. It is this, it is this. All right, let's see what people say. So you say right now in this moment, it is below 32 degrees. Can it right now be in this moment, right here, right now? Was there how that song goes? Things tricking me. Can it be below 32 degrees? And look, we did a lot better. They are completely disjoint. They're completely disjoint. It can't be. It can't be that these both are true. They're completely disjoint. We'll do one more because we got really good on that. Okay. And now we go here and we say it's snowing outside, car fail. And then we'll be doing independent Ashna next. We'll be doing that one. Then yeah, so I'm going to focus in on that. Thank you so much, Ashna. So this one right here, the ones I have circled, are they disjoint or not disjoint? I did this with my class yesterday, and I want to get people to see that this is how you ask. You say, okay, it's snowing outside, and you can just use this sheet right here. This is the cheat sheet. W class yesterday. W class always, because we're morbed in. We're always morbed.
Let him cook. Let him cook now. Let him cook. I said let him cook.
It's morbid time.
There we go. These are not disjoint because they can both occur. It could be the case that it's snowing, and it could be the case that your car fails. Your car can fail, and it can be snowing at the same time. So they are not disjoint. Allie, you got it. Allie, great job right there. That's the exact thing I want to hear. That's what it means to be not disjoint. Morbed in. So here we go to these, and let's look at these to see if they're, and this is the rule for, I need to make it a little bit smaller so it doesn't go off the screen so you can see the full thing. This is the rule for the multiplication rule, which is two things need to be independent of each other. Allie's cracking me up. So we'll go with the following. Let me cancel the last poll. We'll do two of these, and then we are Kahooting. I know it keeps saying we're going to Kahoot. So let's go with, it's above 80 degrees. And it's snowing. So are these independent or dependent? And so this is, and someone asked, how do we tell if they are independent or dependent? This is the steps for independent, dependent. So how do we do, what do we do right here? I'll tell you how to do it in a second. So you say, it is snowing. That's what you do here. You say, it is snowing. Does that in any way impact the probability of me thinking it's 80 degrees today? What do you say? Would you say yes or no to that in the chat? It is snowing. Does that impact what I think about? Yeah. And Dylan on fire right there. Yeah. And that's where if they're completely disjoint, they are dependent. Be careful it doesn't work that things are dependent or disjoint. But if one occurs and the other can't, that means they're completely dependent. Like snowing depends on the temperature. If it's like 80 degrees outside today, it can't be snowing. So these are 100% dependent. You could say the temperature outside or snow depends on the temperature outside. You can think of, there might be a rational on which way it depends. Pretty good. We'll try it. So once again, ask yourself, if this is occurring, does that impact the probability of the other? Does it make it more or less likely? Now, so on this one we have, we'll do, this is the last one. I mean it for real this time. School is canceled, UT official. School is canceled, UT official. And this is your car fails. And you're a student. We had a lot of fun with this one yesterday. People were like, well. There was a lot of, what if? And I was like, don't go too far with these. So what is your answer for this one? We worked on this one yesterday. School is canceled, UT official, not like your one class. It's like UT official, cancel school. So you would say, school is canceled. Does that impact in any way my car failing today, having a problem? And the answer is what? If school is canceled, does that impact your car failing? Does that impact your car failing? In the chat, you can answer yes or no. If school is canceled, does that impact your car failing? And Allie, be careful. Both happening at the same time means they're what? Allie, you're right. Allie, you're right. They can both happen at the same time. One not impacting the other means they are independent of each other. Both happening can happen at the same time means they're what? Because independent means if one happens, it doesn't impact the probability of the other. But the idea of both happening at the same time means that they are what? Because school canceled and your car failing are what? If they can both happen at the same time, they are what? And that's why I like to review, like, they're jointed, they're not disjoint. So they have an occurrence where it could be the case that D and E occur at the same time. That's what jointed means right there, visually speaking. They're not mutually exclusive because they can occur at the same time. Does that make sense? Who feels like they understand this a little bit better? Because there are questions that test your knowledge of this, and you have to figure out if things are disjoint, independent, mutually exclusive. And remember, these are two separate ideas. Disjoint means something different than independent, so you have to make sure you understand very clearly. And I want to give a huge shout out. People practice right here. Can you draw out disjoint and not disjoint? So disjoint would be the events in blue right here. Not disjoint. This is not mutually exclusive. Not mutually exclusive. Where these right here in green, where you have B and E, are mutually exclusive. Like, mutually exclusive means if it's above 32 degrees, it can't be above 80 degrees. There's no overlap. But there are days where there is no school and your car fails. Does that make sense right there? So this is what mutually exclusive looks like. If one is occurring, you can't have an overlap of the other thing occurring. Where not mutually exclusive means if one occurs, the other can occur. On the test willing answer, the test pretty much says, like, are these things disjoint, mutually exclusive? Like, very clearly, it won't be yes, no. Because that was the thing yesterday, too. Like, I had yes, no, and I was like, I think people are confused because I confused myself. Okay, you know what time it is. I already got it up in the background. We're going to McLovin Island. Let's do it. There we go, McLovin Island. Here we go, exam 2 review. Colin all the way from Disney. You might have, did you text me yesterday, Colin? Because I got a new phone. I bought the brand new iPhone, and I got my Nightwing on here, wearing my Nightwing shirt today, and I don't have all the names in there, and I got to add names. I was like, I think I know this person, and I don't have the lines of text anymore from people. But shouts to Colin right there, all the way from Disney. Exactly, a new phone. Who dis? Is that okay? Then text me and be like, yeah, Brian, it's me. Yeah. So I was like, I think I would know, but it literally, all my texts are brand new. Like, it's like I lost all the text lines, and then I tried to merge all my contacts, and it didn't bring them all over. It didn't even merge my wife's contact right. I had to redo. We put a new picture and everything. Brian sweat the legs on Vaultec employees to get. Shout out Vaultec. Vaultec is really good. Okay, here we go. Starting the Kahoot. It is time to Kahoot. Brian's gone Hollywood on us. I went from the iPhone SE, the cheapest iPhone there is, to the iPhone 17 Pro. Didn't go Pro Max, so I need the bigger size. Have to run, but thank you so much, Colin, right there. Shouts from Disney. I don't want to say this as we're getting started right here. Be logging in, be starting the Kahoot. I'm going to timestamp this, but my number one thing with students is I want to hear you make your dreams happen. Colin, I don't think will mind if I say this. Colin took the class like 5 or 6 years ago. He took it 2019. Yeah, but like, knowing that he's doing a job he wants, where he wants, doing those great things, still swinging by to say, hey, that means a lot to me. And I want that for you. You don't have to, you can come say hey to me. I like it when, like, RotoWave's been swinging by a lot. RotoWave's awesome. I used to see RotoWave right out there outside the Student Union. We were talking about that yesterday during a live stream. Check out yesterday's live stream where we do a lot of the work for the upcoming homework and quiz. And I'm glad RotoWave's having a great time. I want you to get the job you want. I want you to have the career you want. And I hope that this class and the knowledge of statistics can be a part of that journey. So that's my hope and my goal. Rotowave is awesome. Yeah. Oh, it goes by Rotowave on here. But yeah, tell Rotowave I say he's awesome. And a lot of people, even Lucy was out there today. So big fan of the name I've got today. Nice, John. But I will say this. My last comment, we're going to start in about 10 seconds. Let me put a timer on 30 seconds so we start, and then we'll start. I keep saying head teachers like, don't say When you graduate, if you get a really awesome career and you're doing awesome things, you don't even have to give money back to UT. They love it when you give money. But come back and try to employ students. Come back and try to help students get jobs and opportunities, because I'm sure that's what we all want right now. We all want jobs and opportunities. So I've been telling this to students for like 3-4 years. You know what? I see some of them back, and that makes me smile. So come back, give back, even if it's not monetarily. Think about how you can help other students in their career, and remember this time in your life. With that, it's time to Kahoot. Let's do this. 3, 2, 1. Kahoot. Vols help Vols. You know what we're talking about. Time to Kahoot. Mubot's even excited about this. The first question is, 2 events that can be easily added together must be what of each other? Go look at the formula sheet for this if you don't know it. 2 events that can be easily added together must be what to do it? Go look at the formula sheet if you have not done it already. We did a little lecture review before this. Got a lot of time. Once again, the formula sheet has this. I'm going to pull up the formula sheet, and I'll show it to you in the background. Formula sheet can be found under Review 2. You can even go to Review 3. You're not going to see the screen for a second here, because we're going to go right over here. And then we're going to go to Formula Sheet. And what do you notice? Do you see it? Who sees it? Addition rule, all that good stuff. Let's go back to the screen. There we are. And now notice, I just want you to notice we're very even across. When do we check independent? When do we check independent? When do we check independent? You get the formula sheet for the test. When do we check independent to see if we can what 2 events? When do we check independent? Multiplication rule. Great job, Reese and Kira right there. Throw some points in the chat. When you can multiply. And who notices that the formula sheet literally has, we can do the probability of A or B by adding together A plus B if they are mutually exclusive, which means if one happens, the other can't. So does yes or no in the chat, just yes or no, Y or N, does the formula sheet have the answer to that last question? Does the formula sheet have the answer to the last question that we can easily add together events if they are mutually exclusive? There you go. And don't worry if you got it wrong. You're here to learn. If you were getting things all right, why are you here? I like getting questions wrong. It means we got to learn. You don't know what you don't know till you get it wrong. Getting things wrong feels bad. I just want to say this. You ever go to the gym? Does it feel good when you go to the gym and you're lifting weights? And I got to go to the gym more. Been taking some time off, healing up from injuries. It doesn't feel good, right? But that's because you're growing. You're getting stronger. So if you're at the gym right now, let's do the next question. This is the stats gym. So don't worry, there's going to be a little pain. There's going to be a little struggle. We're going to get smarter. You got this. Logan's at the gym right now. Nimble, Jellyfish, Legend, Firefly, Focus, Dugong. Wait, did they just go higher up? Or did I delete somebody? I don't even know what happened. 2 events that have no influence on the probability of each other are said to be what? 2 events that have no influence on each other are said to be what? Yeah, there is only one answer to this. I was fearful there might be a second answer. 2 events that are said to have no influence on the probability of each other are said to be what? What are they said to be? Can anyone give 2 events? Like, what would be independent of, let's say, you going out to dinner tonight? Nice job. They're independent. Independent means if one thing happens, it does not influence the probability of another. And you could think the probability of you going out to dinner tonight and your favorite sports team winning. Why are those things independent? Like you going out to dinner in a frog costume. Great job, randomized. Why is you going out to dinner? Nice job, Peyton. Why is you going out to dinner independent of your favorite team winning? Why is and you gotta be careful because you could think the other way. Like if my team wins, I'll go out to dinner. So you could go that way, but we'll go only the directionality of like you going out to dinner and then your favorite team wins. Like almost like it's a thing that happens. Exactly. It's not going to influence. And you're not making a choice based on if they win or lost, because someone could go that way. Like your team winning, you go out to dinner. That could be dependent. Like you're excited, your team won the Super Bowl, so you go out to dinner. But if you look at it only in the directionality of like you go out to dinner and then your team wins, there's going to be an independent right there. Like your team in no way, as far as we know, unless like you see your favorite player and you're like, you got this, man. He's like, yeah. And then he does better. Don't go that deep into this. Going to Taco Bell does not affect LeBron. I mean, what if you see LeBron at Taco Bell? Let me put as a quote of the day right here. Quote of the day, 554. Quote of the day, going to Taco Bell does not affect LeBron. So that's what it means to be independent. If one thing occurs, it does not impact the probability of another. So if the probability of you going out to dinner from events that have occurred is 20%, and the probability your favorite team wins is 50%, what's the probability you go out to dinner and then your favorite team wins? What's the probability you go out to dinner and then your favorite team wins? So what's the probability you go out to dinner and then your favorite team wins? What's the probability of that? You go out to dinner and then your favorite team wins. Exactly. Does that make sense? Like you just multiply the probabilities, but you have to check if they're independent before multiplying, because you just say like the probability I go out to dinner is 20% of the time. So what's the probability on a random night I go out to dinner and my favorite team wins? And it's that sequence of events. Like on a random night, only 10% of the time do I go out to dinner and my favorite team wins, because you don't go out to dinner that much. You can't have Taco Bell every night. Might try. Mesmerizing Kingfisher. Man, they made new names in this. Legend, Firefly, and Focus. Dugang. Here we go. Next question. To multiply the probability of A and B, these two events must be what? Look at the formula sheet. Really hitting these home right here, because there are questions as simple as this on the test. To multiply the probability of two events, there are questions that just ask you this. So everyone, what should you be doing right now to get this right? This is like my test to make sure you know. Look at the formula sheet. A lot of this is like training you right now. You have to know how to lift the weights before you lift the weights. Cole said, look at that formula sheet. Look at the formula sheet. Check the formulas. When can I multiply the probability of A? It says probability of A and B. Yes! We're doing better. We're doing better. Well, that's all right, Working Bird. Glad to see you here, Working Bird. And if people need, swing by second floor SMC, and I could print you a formula sheet. We still have it highlighted right here. The probability of A and B is the probability of A times B. Two things need to be independent to multiply them nice and easily. And then when you add things, you're using mutually exclusive disjoint. Check out the start of the video where we go over that. Here we are with the next leaderboard. No Nimble Jellyfish, Honest Rabbit, I like you, Honest Rabbit, and Zany Nightingale. I got to show this really quick. Today, I was walking around catching Pokemon, and I saw the coolest Pokemon ever. I think I have it in here. This is insanity. Let me go forward in this. I didn't touch it, of course. I'm not going to touch it. I saw a little baby squirrel. You're not going to be able to see it. I saw a little baby squirrel. It was the cutest thing ever. Of course, I did not touch it. You don't touch animals. I don't want to be touched. There's the little baby squirrel. Little baby. 30x zoom. So anyways, I should post a picture of it on the Discord. Check out the Discord. I think I'll post. It was so cute. But so its mother was like holding it. I was like, what is that squirrel holding in its mouth? It's like a football. And then it moved. I was like, that's a baby squirrel. So exactly, tame squirrel that carries around. Oh yeah, that dude. That's pretty cool. Here we go. Next question. The probability you get a gross jelly bean is 25%. If you eat 3 jelly beans, what's the probability they're all good? Now, this is the probability of a gross jelly bean. What's the probability of a good jelly bean? Oh, there we go. I think you randomized. What's the probability of a good jelly bean? Good to see you, Sarah Lindsay. What's the probability of a good jelly bean? Let me give Sarah Lindsay a shout out here with this one. 75%. So when you eat 3 jelly beans, the first one is good, and the second one is good, and the third one is good. Did everyone hear that? When you hear me say and, like the first is good, and the second is good, and the third is good, each jelly bean must be what of every previous jelly bean. The first one was good, and the second one was good, and the third one was good. And Kira's hearing the multiply, you're right. And each jelly bean is independent of the previous one. That means if this jelly bean is good or bad, it does not impact the next jelly bean. Does that make sense? It logically makes sense. So when you think about this, all we're doing is multiplying by how many jelly beans there are. And we'd say the first is good, 0.75, times the second is good, 0.75, times the third is good, 0.75, which reduces down to 0.75 to the third power. And mutually exclusive means they can't occur at the same time, like a good and bad jelly bean can't occur. Your jelly bean can't be, you can't be like, this was a good jelly bean, this was a bad jelly bean. It'd be two separate jelly beans. And we did pretty good on this. Well, this is the probability of a singular good jelly bean. This is the probability of 3 good jelly beans in a row. And if they're dependent, there are different formulas not used in this class. Came in 5,000 points for asking that right there. We won't multiply them. In this class, we won't multiply them. We'll leave that for an upper level class on probability when you deal with given something occurs, how it changes the probability, like A given B. Believe me, there's whole classes on probability. Guys, I want to give a shout out to Sarah Lindsay right here. Sarah Lindsay's on the Discord, so you see the pin message right there. They do so much promotion of what we're doing. They answer so many questions. They also are a tutor and a top-tier tutor. It is paid tutoring where you figure out the times, you figure out your schedule, you figure out the payments and all those things. I think they might even do group tutoring. Sarah, you're more than welcome. I'll pin a message right here if you want to do an advertisement for your tutoring. But as the semester goes on, if you're interested in getting some outside tutoring, I highly recommend Sarah Lindsay. A lot of students have said a lot of great things, and they're always there. They give a lot of free help too, which they can do whatever they want. I'll still promote them if they don't give any free help because I've heard many great things about their tutoring. So check out the Discord also. Some questions get asked here and there. Sometimes at the end of the semester, it gets really busy, and I try to look in the evening and see what's going on. I might miss some things, but check it out. Are we covering the earlier chapters from Exam 2? We will. Check it out. We got it coming up. So here we are with the leaderboard. Nimble Jellyfish, Honest Rabbit, Zany Nightingale, Mesbrine Kingfisher. Here we go with the next question. The probability of getting a multiple choice question correct is 80%. With 5 questions, what's the probability you get at least one wrong? And there you go, the email in the chat and all that. I'm going to make that the pin message. So in these problems, I'm going to take a screenshot of this. I'm going to work it out. These problems give people a lot of issues. I think you can still see your answers on the screen. You need to write a sentence. Write a sentence for these. Write a sentence for these. So you're either going to get at least one wrong or what? You're going to get at least one wrong or what? Like when you take a multiple choice test and you studied, you're going to get at least one wrong or what? Or everything correct. Or all correct. Now, since this is everything that can occur, because you'll either get at least one wrong or everything correct. Now, the reverse of that, John, is you'll get none wrong or at least one right. Like if you go that way, there is a different way to ask this. But since this is everything that can occur, this has a probability of what? What is the probability of this? Because you're either going to get at least one wrong or you'll get them all correct. What is the probability of this if you either getting at least one wrong or it's one? Because not two, 100% probability. And so now check this out. Or means what? And these are disjoint because they can't both occur. You can't get at least one wrong and everything correct. So, and Wilson, great job, Wilson, in the chat. And everyone's already solving it. We turn this into a plus because or is addition for things that are disjoint. And then we algebra this over to the other side. And we get 1 minus, because it has to be minus, 1 minus all correct. So if the probability of getting 1 right is 80%, the probability of getting all 5 right is getting the first one right, and the second one right, and the third one right. And that's going to be equal to the probability for all correct, which people are already writing here, 0.8 raised to the 5th power. And that'll solve it out right there. Great job, Allie and everybody. I feel like people have these. Who feels like the sentence method is a good way of doing this? Practicing these and knowing how to write your sentence, that you're either going to get them all at least one wrong or all correct, and then solving it out. The sentence structure I've created, I don't know if I created it, but once I figured out how to step through it like this, you get it right a lot better. You get it right more often. How did we do on the question? It's a tricky one. Oh, see, it's a tricky one. It's tricky. That's, yeah, exactly. It takes practice. We'll do one more of these right now. I want you to see if you can solve it. It's my favorite question about the sodas. We'll just do that one, which is on the homework. Okay, so Coke has a game where 10% of the caps are winners. if you buy a 6-pack, what is the probability you win something? Okay. Oh yeah, we'll go right back to it. Yeah. Or Ben, sorry, if you want me to go back, let me know. So, what is the probability you win something? So we want to figure out the probability of win something. What is the complement, or what is the other side of it? As in, you either win something or what? When you buy a 6-pack, you'll either win something or what? You could win 3 times, 2 times, 1 time, 6 times. Win nothing, exactly. And one of these things must occur. And actually, great job right there, because if you win nothing is the same thing as saying all losers. So what's the probability of all, and randomize on fire right there, and people are already solving it. The probability of all losers is going to be 0.9 to the 6th power, because it's the probability of losing is 90%. And then you simply just do this right here, algebra over to the other side, this. And once you get these down, they are so quick. Who's done like five of these, and then like Peyton right there, who's done a bunch of these and will put the difficulty at like a 2 or 3? Like, they're not that hard. Like, these look like very hard problems till you realize you just got to write that sentence. Like, you either win something or you win nothing. What's the probability of winning nothing? And each Coke is independent of the previous one, so you can multiply the probability you lose and 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 you lose. Once you know how to read it, it gets way easier. And there's just a specific type of problem which only accounts for like 4 to 5 points on the test. But you should know, yeah, this layout right here, Jennifer, really helps. Like, write your sentence, solve it through algebra over the side. Nice job, Matthew, right there. Or Wilson, sorry. Yeah, awesome. Let's go back to the leaderboard. Okay. Nimble Jellyfish, Amazing Honeybee, and Zanny Nightingale. What is the first thing we need to do when solving a sampling distribution problem? And I'm going to tell you the answer. Figure out if it's categorical or quantitative. So mark that answer right here and let's talk about it. So that is the answer. The reason you don't do these other ones is because if you're finding p hat, that's only for categorical. The p-value, that's if you're trying to figure out if something's likely or unlikely. Marking the notation, I could see why a lot of people might say that. That might be an answer if people didn't hear what I said. But before marking notation, you need to know if it's categorical or quantitative. So before marking notation, you need to know if it's categorical or quantitative, and the formula sheet clues you in on this. So here's the formula sheet. So do you see this right here? Let me give you a classic thing that was asked to me by a student. So here is what a student one time said to me. We had a problem like, you work at a heating company where you make 10,000 heaters a year, just you. The average heater has a lifespan of 5.5 years and is normally distributed with a standard deviation of 1 year. You sample 100 heaters. Is it unusual that these heaters only lasted 5 years? Okay. Now here's the thing. This question tricks a lot of people. So this question would trick a lot of people. Answer, is this unusual? Yes or no in the chat. And you're probably doing immediately what a lot of people do because they're thinking chapter 5. So let's mark our notation. What is P? What is Q? What is P hat? What is Q hat? So let's mark the notation. What is P in this problem? Got the point button ready. What is P? What is Q? What is P hat? What is Q hat? Need to find P. Need to find Q. Need to check success failures. What is P? What is Q? What is P? What is Q? Any comments? Any thoughts? These problems trip people up. They don't know how to do them. Well, so what is what? I need something equals something. Randomize said it. Did everyone hear what randomize just said right there? That means, or we can do it easier. Do you see all this proportion stuff? that does not apply to this problem. I had a student tell me, Brian, I can't find P in this problem. Does that make sense? Well, in P and Q must be numbers between 0 and 1, but it only applies to categorical data, which is yes, no questions. Like, do you like Taco Bell? Or did you order mint chocolate chip? So since it's the mean, there is no P, there is no Q. The first thing to identify with all of these problems are we working with, and Sarah's got it right there, and other people got it. The first thing to identify is this is quantitative because we're doing the average heater has a lifespan of this. So what is this quantity right here? So identify what that is in notation. That says the average heater has a lifespan of this. The average heater has a lifespan of this from our 10,000 heaters. Be very careful though. What is that? The average heater has a lifespan of this. What is that? You have to know the notation. And I'll say what it is in notation in a second. Just take a guess. Probably. Well, if you see this, it's, and Jennifer, go into more, Jennifer, you're right, a little more detail. And Kira's got it. That is mu equals 5.5. There we go. Proportions deal with yes, no questions. That's what you want to see. Like, are they asking, did they order mint chocolate chip? That's going to be proportions. Are they asking, how long does the average heater last? And thank you right there, Sarah Lindsay. Great answers in the chat. And what is, can anyone identify any other notation? I'm going to circle the things we need. Say this equals this. Identify the other notation. We're going to quickly work this problem, go back to the Kahoot. This is a very good problem to work. Identify anything else in this notation. Yep, that's the sample size. N equals 100. Any other notation? Sigma equals 1. Yep, nice job, randomized. And what is 5 years? It's unusual. These heaters, it's talking about the sample of 100 lasted 5 years. There's no P. There's no capital P. There's no P in this. And then if you ever have P or Q, they have to be between 0 and 1. Nice job, Charlie. That is the population. Yep. And then 5 is the Y bar. And you can kind of see if you go through here, you will identify a lot of the notation within these problems. You should have a lot of it. But does everyone notice right here, you are getting a lot of things that are in this problem and sigma, but you will identify from the notation that's given to you pretty much all of it. So we can solve out a lot of these things right here. So what we would do here is, and this would be a very good problem on a test, because we might say, what is the z-score of this? Did anyone already find the z-score of these heaters? This is the last part of this. I'll start working it, but I want to see if you can get the z-score before I show you the answer. I know the z-score in my head because I did some nice numbers. So with this right here, we would simply go in and we would do mu y bar equals mu. And that's just equal to 5.5 because that's what mu is up here. And then the standard deviation of y bar is equal to the original standard deviation divided by the square root of 10, so it's equal to 0.1. Very well, careful. This, do you see it? I'm gonna throw everyone some points. Careful. Randomized, yes, that's the trick. That's where people make the mistake. It's because the equation, if you take a look, I'm gonna highlight just this. In the equation, you don't use the original standard deviation, you use the standard deviation of y bar. A lot of people take and plug this in the bottom, and that's where the mistake happens. That's what I wanted to point out here is a lot, and I mentioned it last class, that a lot of people do in this equation 5 minus 5.5 over 1, but that is the original standard deviation. You don't use the original standard deviation, you use the new standard deviation, which is here in yellow. Who follows this right here and is like, oh, we have to do the standard deviation that is the smaller one for the standard deviation of the sample mean. So that's the standard deviation of the sample mean, not the original standard deviation, because that got divided by the square root of 100. And I wrote 10. It is divided by 10, but square root of 100. Does that make sense? So is this unusual? Yes, it's 5 standard deviations below the mean. So standard deviations to the z-score, exactly. So that's a huge, I think we teach you the normal curve to start, and then it's like, okay, well, now the standard deviation is going to be the new standard deviation based on a sample of this size, and that's where the mean stays the same, and the standard deviation gets smaller, and the curve gets tighter, according to the central limit theorem. Oh, so you wanted the z-score of the, yes. Is it unusual that these heaters, like as a whole, lasted on average, I should have said on average 5 years. It could have been worded a little bit better, but it's not like one heater lasted 5 years. It's that they averaged 5 years. So lasted on average. That would have made this lasted only on average. Like it was an average of 5 from 100 heaters. So that'd be very unusual to be like, why'd those heaters last that long? Okay, good sampling question review. Let's do the next part. Nimble Jellyfish, Shimmering Panda, hey, good to see you on leaderboard, and Zany Nightingale, Glowing Goat, good to see you too. When trying jelly beans, if you take 2 jelly beans, what is the sample space of good and bad jelly beans? Once again, very much like your test questions, and a little bit easier too. Sample space is defined as what? You should have a definition. Do we say it's yeah, exactly. It's like more than 3. 3 is very unusual, 2 is kind of unusual. So Reese, you could say that right there. It's unusual because it's more than 3 standard deviations away, which is a pretty big outlier. You wouldn't expect to see that. Yeah, and Jude right there. Sorry if it wasn't a clear enough question. I was kind of... Yes, the sample space is all possible outcomes. So when you think about, and it has respect to order too. So if you look at boy, girl, the sample space is going to be everything that could occur with boys and girls, boy, boy, girl, boy, boy, girl, girl, girl. And it is respect to order too. What is a sample frame? So what is the sample frame from chapter 10? What is the sample frame? What is a sample frame? What is the sample? You want these definitions in your notes. What's a sample frame? List from which we draw a sample, like all people we have access to. All people we have access to, or all things we have access to sample, not necessarily sample. So if you are interested in understanding UT students, you go to the library at 8 a.m. and talk to 100 students. What was your sample frame? You are interested in understanding UT students. You want to understand UT students. So you go to the library at 8 a.m. and talk to 100 students. Yep. The population would be UT students. Sample frame would be students in the library. And then sample is 100 students talked to. And what people have to remember is the sample frame is very theoretical. It's that anyone in the library you could have technically spoken to, like, what are you sampling from? Does that make sense when we call it a sample frame? Like, what are you sampling from? Like, we could say, why don't we just call it the people you sampled from? You sampled from people in the library, and you wanted to understand UT students, and you talked to 100 people. That's your sample. So the sample frame is the people who, or things you have access to sample. So it would be probably a bad sample frame because you're only understanding people in the library. So that's not really indicative of all UT students, or a good representative sample, which is what we want samples to be. Okay, Shimmering Panda. Oh, look at the cool hat. Zany Nightingale and Glowing Goat. Next question. What 3 values will you have to write interpretations for? And I will say there's a small update to this. I think Terry's making some changes. It might be 8 points. It might be 12 points. It might be fill in the blank. But you need to know how to write interpretations or know how to talk about them. Isn't GB and BG the same order? Order does matter, yeah. Because it's possible to have girl, boy, or boy, girl. Like the boy is the oldest or the girl is the oldest. Don't worry. I think the test makes it very clear. But when you think about the sample space being everything that could occur, we could say it could be that you have a girl, then you have a girl. It could be you have a girl, then a boy then a girl, or a boy, then a boy. And it is, girl, boy is kind of the same thing. There's one boy, there's one girl. But with respect to order is very important too. Like the idea of like, well, it could be that the boy's the oldest, or it could be that the girl's the oldest. With the interpretations, Mubot's got them in the chat. And let me write slope, intercept, r squared. And Jude's like this very, and I think I might have, I got to cheat because I'm remembering what comes next. I'm going to go here and cheat and look so I can see the question before we get to it. So, okay, let's do it. So right now, what I want you to do, yes, exactly. And I think there might be some changes, Sarah. I mean, I'm kind of giving it away. They might be worth 8 points now. Someone's not listening. I mean, like someone's got this on like mute or something. But they might be worth 8 points. There might be updates to this. We were talking yesterday, giving a little inside baseball here. Kind of, sort of, Jonathan. So I want you, we're going to go grab some data right here. I want you to take a screenshot of this, or I'll make up my own fake data. So when we write a regression line, I think it's still worth about 8 points, I hope. People hate the questions, but I love them. And then we just have to, one problem we run into is like consistent grading. Because I've looked over some of these and I'm like, that's not graded right. Like I saw one that was like 4 points and they barely answered it. I was like, so we have to worry if we usually have great graders, but every once in a while grading doesn't meet the mark, and then we either have to regrade, talk, and work through it. So here we go. Here's what we're gonna do. Oh yeah, we're gonna do that. We're gonna do some R-squared and intercept and slope right here. So here is a model explaining, let's say, how many reviews you go to. So students either go to 0, 1, 2, 3, 4, or 5 reviews. And the data is actually going to look like this now. It's going to be I got those perfectly. And it's not perfectly linear, but it's straight enough. Straight enough. Okay, that's good. And let's make it more linear. Good, now it's straight enough. Fit the data to the model. So what do you notice about this? Your exam 2 score. And what do you notice about this? What do you notice about reviews and exam 2 score? I'm just making this data up. It's not like if you don't go to review, you're going to fail. It's not how this works. It's not cause and effect. What do you notice about this? More reviews, you generally do higher. And it's not like if you go to reviews, you will pass. That's where you got to be very careful because that sounds cause and effect. Positive linear relationship. We'd probably see that, I think, if we had the data on it. Y-intercept. Ooh, the Y-intercept it should be 0. The Y-intercept should be 0, though. That should be 0. So let's say the model has this. If the model has exam 2 predicted equals 70 plus 6 reviews. Let's go to who's got this equation. We'll drop it in the chat. You ready? I'm going to pin it. Exam 2 equals 70 plus. The next Kahoot questions are easy because it's a little hard. Okay, so we've got this pinned right here. And let's go back and do the Kahoot question for it because it's really easy. Leaderboard. What is the interpretation of the slope? Write it in the chat. Write it in the chat after you click a button. I used to have these more written out, and then I was like, it didn't really work. I want you to write in the chat, though. Interpret the slope in the chat. I'm not going to do it till someone does it. Mubot will give you the general slope interpretation. I think 28 or so. Oh, exactly. Nice job, Ashna, and randomized. And there we go. If you notice, they're following for each additional review a student attends, we expect their score to increase by 6 points on average. I'd throw that little on average on there. If a grader took off for not putting on average, I'd be like, whatever. And it could be increase or decrease. Mubot has that increase or decrease. For each additional review you attend, the model predicts your score to increase or that the students would be higher by this amount. Like, it's not like you will get a higher score. Never use words like will or cause or like your score will go up by this. No. For every increase in one review session attended, it's expected for the exam score to increase by 6 points on average. Yeah. Does that make sense right there? For each additional 1 unit increase in X, and we'll go view it again. And you should see it, you should visualize it and look at it and be like, oh, like the slope is this right here. Does that make sense? The slope is that. Like this unit of 6 difference is related to a 1 unit increase in exam review. So for each additional review someone attends, we would expect, not that they will, because like this person did lower than that person who attended less reviews. It's an expected difference between 2 people who differ by 1 exam review. It's expected that they would differ by 6 points. Okay, I'm going to put right here the R squared is equal to, I'd love it if it was that. We'll use that later, but make sure to look at the pinned question as we go to the leaderboard. Glowing Cat, Zany, Nighting Wolf, and Shimmering Panda. What is the interpretation of the intercept? Go ahead and write it. And is it logical? Because not all intercepts are logical. An illogical intercept would be like when your height is equal to 0, we expect your weight to equal -20. Well, you can't have a negative weight, and you can't have a height equal to 0, as far as I know. So there are illogical intercepts. It's when like the value of X cannot really equal 0. And there are illogical Y values like a negative Y value, like you can't have negative height. So who's got the interpretation of the intercept? Look at the pinned comment for how we, the equation we're using. For a student with 0 review sessions, we would estimate a score. That's great. I'd give full points. Ashna, great answers right there. 5,000 points. When a student does 0 reviews, the student is expected to score a 70. Yeah, the expected score, when you don't do a study sessions, your estimated or predicted score is 70. For students who go to 0 study sessions, their predicted score is a 70. When X is equal to 0, we expect Y to equal B0. Exactly. For students who go to 0 exam reviews. And thank you so much. Everyone's practicing right here. This is the way to get it down. Here's the thing. Take Mewbots. Mewbots got this in the chat right here for the intercept. Make sure you write this down and practice it and just know the formats. When a student goes to 0 review sessions, we expect the student score to be a 70. When a student does 0 reviews, we expect their score to be 70 on average. Nice job. On average is good too. And it is logical, Peyton. You are correct, because it's like you could go to 0 reviews and you could score a 70, and those are like logical scores. Not saying you will. Okay, let's check out the next one. Glowing Cat, Zany Night Wolf, Shimmering Panda. We'll do one more right here. We decided to talk to students in the dorms and talk to all students who live in Brown as a sample. What kind of sampling did we do? There's a key element to this one. Someone could put the word in here, but we definitely did this. It might not be a perfect example of it because it's not super representative, but this person did a what sample using Brown as that what sample. Jude's got it. It's a census. Notice the keyword census, and notice the first letter of census, because a census means you took all of one group, and Brown was the cluster. Brown was the cluster. Stratified, you have to acknowledge differences. And if we took like 20 students from each dorm to ask them their opinions of dorm life, that would be stratified. Does everyone hear if you stratify by dorm, you take 20 students from each dorm because you're acknowledging differences between. And as Peyton said right there, CC, because when you hear all from one group, that means a census was done of a cluster. So you could say something like, I'll do 2 examples right here, because I like to differentiate between these. We go to Nayland Stadium and talk to everyone in 5 rows to gather data on how good tickets are priced. We go to Nayland and talk to 5 rows in students and 15 rows in general admission to get views on how tickets are priced. All people are sampled in these rows. Okay. This first one right here is what? Is it stratified or cluster? This first one, is it stratified or cluster? I put a push button late. People might already say, is it stratified? This first one right here, is this stratified or cluster? We go to Neyland Stadium and talk to everyone in 5 rows together how good ticket prices are. We talk to everyone. We go, hey, this row right here, you've been selected. We're asking everybody in this row how good are tickets. Then we go to another random row in the stadium. We say, hey, everyone in this row, we need to talk to you about how good tickets are. And someone in another row is like, hey, I want to talk to you. And we're like, no, you're not in this row. We're taking everybody in this row right here. So does anyone want to explain? We're doing a little better on it. So everybody in a row is taking a what of the row? A census of the row. Because you're getting everyone in that row. So that row is the cluster. So clustering is used to speed things up. And you talk to everyone in the row. So that is the cluster, is the rows, the 5 rows. Each row is a cluster. But what are we doing down here? The rows are still the cluster. But what is the bottom one? What is the bottom one technically called? The first one was a cluster because we did the rows themselves. Yeah, exactly. I think, Elizabeth, you're right. What's the second one doing? The first one doesn't acknowledge any differences. It's just 5 rows. Exactly. Jonathan, you're right. First one's just like, take 5 rows of people in Nayland. Working Bird on Fire. The next one is a multi-stage. The next one is multi-stage with stratifying by type of ticket and then cluster sampling. So it's stratifying on type of ticket and then cluster sampling on taking rows as samples. So, and I've highlighted right here, this is the stratifying. The stratifying is acknowledging the differences between a student ticket and a general admission ticket. And you're stratifying right there by acknowledging the difference. And then you're taking proportionally, like there's probably more general admission, like I'm doing a 1-to-3 ratio. You would do it like only 25% are students at Neyland, maybe less. But you would then do this right here. Nice job. That is a multi-stage with stratified, then clustering. Okay, leaderboard. What is an example of just stratifying? Let's do that one really quick right here. Thank you, Charlie, for asking that. An example of just, does anyone want to drop one in the chat while I write out my example? And I'd have to know the ratios. So you talk to students about dining options on campus. You speak to 200 commuters and you speak to 150 on-campus students because either someone's commuter or on campus. And the way someone feels about dining is probably related to, do they live on campus? Do they commute to campus? Exactly. Kira's got to have used this example in class. And this would be stratifying because you're not taking all the commuters and all the on-campus students. You could do an element of like cluster sampling to talk to people. You go to the dining halls and sample from each dining hall 5 random tables of students. Now, here's the thing. There's actually a second, hear interesting noises. There's actually a second stratification in here. Who sees the second stratification? Who sees the second stratification in this problem? Who sees the second area of stratification? There's the cluster. The dining halls. Because then you're going to go representatively from each dining hall. So you're saying, like, we need to get 5 tables from each dining hall, and then we need to make sure our sample shows 200 commuters and 150. So stratification is about representation. Does that make sense why you stratify? You stratify to make sure you get proportional samples to what the population looks like. Because if you just go to one dining hall, that's going to be not representative. Clustering is about speeding things up because 5 random tables is just 5 random tables. You maybe have a list of all the tables and you say, well, we have to go to this table here because you don't want to go to like the tables on like the far side or whatever. You want to go to like 5 random tables. So in the tables, so this would be a multi-stage. Yep. This would be a multi-stage where you stratify on commuter, non-commuter, dining halls, and then you take the clusters of 5 random tables. It's like, yeah, exactly. Randomized, you're so right. There's actually strata in dirt. Strata means layers, and there's this really cool picture on Wikipedia. Copy the image here. I used to show this. I just haven't shown it lately. That is strata, where you take representatively from each group. I've seen this picture forever. And strata in dirt. So it's, yeah, great job randomized right there. Yep. Strata means layers in Latin, and strata, stratum, things like that, or the stratosphere. So, yeah, it means layers and separation. They're different from each other. So you have strata that you acknowledge these differences. Yeah, randomized on fire right there. A lot of great answers today. Okay, and thank you so much, everybody. I know we do more than the Kahoot, but it's good practice. What is the best way to know the difference between p hat, y bar, p, and mu? And we're talking about specifically the difference between p hat and p, and the difference between y bar and p hat. Or wait, y bar and mu. I can't speak. Specifically p and p hat right there. What does p mean? What does p mean? What does p mean? Might be out in Utah. What is p? What does p mean? Close a little. It is kind of related. I'll throw you some points. Let's come with p values. But what is p? Don't worry. There's no test question that looks just like this. This is me reminding you to know notation. P stands for true proportion. P is true proportion. I'm going to write all these out for you right here. Try writing them down. They'll be really important for the third test. P is true proportion. That's what P is. What is P hat? Who knows what P hat is? What is P hat? There we go. What is P hat? What is P hat? Where is it? There it is. Sample proportion. Oh no, it's there we go. What is y bar? What is it, man? What is y bar? Sample mean. And it is observed too, Peyton. Like you observe the sample proportion, you see that in a sample. And then what is the true mean? Mean of a sample, yep. The true mean is mu. That's true mean. I'm writing down as much notation as I can think for you on the test. And then is there no sigma here for free? Where's sigma? I'm gonna grab a sigma symbol online. What is sigma? Hearing crazy noises outside. Sigma is true standard deviation. And when we say true, it means for a population. Like true means for a population. Whenever we say true equals for a population. So P is the population proportion. And then S is, lowercase s technically, is sample size. Lowercase n, oh wait, what am I doing? Sample standard deviation. Lowercase n is sample size. Capital N is population size, also used for normally distributed. And B0, not capital B, but lowercase b, sub-0. Good character. I mean, bad guy, but good character. Mortal Kombat 2 coming out. Is intercept. And B sub 1 is slope. There we go. Does this make more sense, or does this help people out? And you can see the difference between like populations where this is a truth, this is a truth, this is a truth, this is a truth, and this is a sample, this is a sample. Sample statistics usually are small lowercase letters, and those are samples. The population versions of those are beta 0, beta 1, and that would be the true intercept, the true slope. Just beta 0, beta 1. Okay. Any questions on this, on the notation of this? Very important to know these things. That's most all the notation. You should be able to know examples of this, but know your notation. Notation is going to be huge for the third test. Third test is a lot of notation. So let me actually bookmark this and say like very important notation for this. Very important. Very important. Like, let me give you a quick quiz. You ready? We go out and talk to 100 students and find that on average, the 100 students spend $20 a week. What is that? Hold on 2 seconds, Charlie. We go out and find that 100 students spend on average $20 a week. So what is $20 a week? What is it on this screen that the students spend $20 a week? Y bar. Because it's the mean of a sample. Exactly. And Charlie asked, isn't p hat being proportion? Did I write proportion? Oh, I can't write proportion. Charlie, thank you so much. 5,000 points, Charlie. It's y bar, sample mean. Exactly. And then 100 would be the sample size. There you go. Thank you, Charlie, right there. And then I guess we didn't put q hat. How do you find q hat and p hat? Or, excuse me. How do you find q hat and how do you find q? Complement. There go. 1 minus. Oh, you're asking about that. I'll show you that answer again here in a second. It's because the difference between p and p hat is that one is for a sample, one's for a population, and exactly, it's complement, true proportion, and this is just 1 minus p. Okay, let's see those answers. I think we still have the question on the screen. So if you look right here, p hat and y bar come from samples. That's the difference between p and p hat. And Charlie's asking about the one that says, isn't p hat being a proportion a correct answer? But it's specifically what's the difference between p and p hat. So it is true that they come from, like, when you think about what's the difference between p, because there's other kind of rightish answers on here. And like I said, there's no test question that does this sort of weirdness. P is for a population. P hat is for a sample. So specifically, what's the difference between p and p hat? One is a sample statistic, one is a population parameter. The population parameter is P. P hat is a sample because P and P hat are both for categorical data proportions. So it's not that answer. P has proportion and Y bars for means exactly like, i.e., what is the difference between? That's why I added this onto here. You are correct that P is proportion. So this is, I will say that if you answered blue, that's not wrong. It's just like, what exactly? Does that make sense? This is not a fair question. It's a fun one. It won't be on the test, but the knowledge of the notation will be on the test. Here we go with the leaderboard. Zany Nightingale, glowing coat, shimmering panda. Let's do the next question. Yes, study the canvas content. The central limit theorem is a fundamental concept in statistics. So what's the right answer? The central limit theorem states three things. I could probably do it. Hey, Hadley right there. Sorry. I'm so blind, Hadley. I've had 2 eye surgeries. The central limit theorem is fundamental in statistics. I'm going to go drop this on the Discord as we speak. Thank you for asking. Always when people say, can you do this as help? I will. What 3 things does the central limit theorem state? What 3 things does the central limit theorem state? What 3 things does the central limit theorem state? I said it's fundamental. What 3 things? You're welcome. So let's go over the wrong answer. States over the long run of repeated trials, we see the true probability. What is this? Oh, John's got it. John's got a good answer. What is, a lot of people answered this, which is a fact in statistics, but what is this? States over the long run of repeated trials, we see the true probability of something occurring. That's not the central limit theorem. That's the law of large numbers. The law of large numbers states over a long amount of trials, we see the true probability. This is the law of averages, which is a fallacy. That's the Pythagorean theorem. So the central limit theorem is fundamental to statistics. And the reason it's fundamental is because distributions normalize, which allow us to use the 68, 95, 99.7 rule and use things like z-scores. So it's fundamental because we can't use these distributions like z-scores or normal distributions with z-scores if we don't have the central limit theorem coming into play. The 3 things that the central limit theorem does for us, and we'll draw that out right here, is when we think about the central limit theorem, think these 3 facts. 3 facts, really, facts about the central limit theorem, which is fundamental to statistics. Okay, the 3 facts are, fact number 1, as n gets larger, data gets more what? As n gets larger, the spread gets water. As n gets larger, the mean does what? And the first one is the data becomes more normal. So the data becomes more normal. And what else? The spread becomes, or oh my gosh, one letter off, becomes smaller. And last but not least, the mean does what? The mean stays the same. And we can see this formulaically if we look at, for this one, sigma over square root of n. If you think about this, as n goes up, this quantity goes down. And the mean staying the same is mu y bar equals mu. Look, there's no n in this equation, so as n gets larger, it's not here. There's no n in the equation, so this just stays the same right here. It doesn't move when it changes. We can also see it in action, visually speaking. If we have a distribution that looks like a normal curve and we sample 5 observations, the mean of this data is going to be 16, and the standard deviation after this simulation is going to be 2.23. Is that right? That's not right. I guess it is 2.23. And if I run more simulations, it should go to 2.2, or did it round up? It does round up. So notice, what happens if n gets smaller? Oh, it's the reverse. So here's a larger n. Do you see how I'm making n larger? So what's going to happen to this distribution? It's going to get tighter and more normal. So you see this right here, it's tighter and more normal. But let's say we have a skewed distribution. So now, this is the distribution of means of sample size 25. So here's 25 observations, and then we get a mean of those. And then here's 25 observations selected randomly, and then we get a mean of those. And we keep doing this simulation, and we build up a distribution. Now notice the new distribution of means of sample size of 25, which was built by taking 25, taking the mean, taking 25, taking the mean, is normal and tighter. So if I decrease the sample size, this will look two things. It'll look what? What will be different about it? What two things will change about this and how, Lee? Technically, if the sample size goes down, it's going to look what? How will it look according to the central limit theorem if there's a smaller sample size? We have to go reverse. So remember, bigger sample size, more normal. Bigger sample size, tighter, because you're dividing by square root of n. So what would happen if there was a smaller sample size? If there's a smaller sample size, it's going to look how? More spread out and less normal. Exactly. So here's the of 2. It's going to look wider and less normal. And here you are, wider and less normal. And notice the mean is still the mean. Does everyone see where the mean is right there? The mean of 11.10? Because the mean doesn't change.
It doesn't matter.
The mean stays the same. And this is where we have, it's more like the 125, 100. And Working Bird, great answer right there. Or maybe I did that in a separate video. This is a skewed-ish distribution. So with the large enough n condition, we need a sample size of at least 25. A sample size of at least 25 will be large enough such that the distribution of means will be nearly normal. And there's really great questions on chapter 14 that go over this, like when is n large enough? And it depends on the shape of the original data. For more skewed data, you need a larger n. So that's why for the original one, when the data is normal, is a sample size of 2 large enough? Yes or no, type it in the chat. Is a sample size of 2 large enough so that the distribution of means of sample size 2 will be nearly normal? And the original data is normal. And the answer is yes, because the original data is normal. It only gets more normal. So if the original data is normal, you don't even need more than 1 because the original data is normal. Does that make sense? But if the data is skewed, you need at least 25 because now a sample size of 2 doesn't normalize it enough. The larger n is, you see how I increase n, the more, so you don't even need that big of an n. Gets normal very quickly according to the central limit theorem, which is fundamental because now, because of the central limit theorem, we can now use the 68, 95, 99.7 rule, and that's why it's fundamental. Let's go check out that leaderboard. My Pokemon Clear is about to fall off the desk. Here we are with Zany Nightingale, Glowing Goat, and Shimmering Panda. Next question. The conditions for the sampling distribution of the sample proportion are condition 1, condition 2, and you'll probably get this one right here, and condition 3. What are the conditions? Condition 1 for the remainder of the semester is random. Condition 2 for the remainder of the semester is 10%. And then you have to pause. You put the pause in the chat. And you have to figure out what the last condition is. Hint, I'm not blocking any of the right answers right now. The last condition is success failure. So we wrote a problem earlier. And let's look at that problem we wrote. And let's change it. So what we're going to do here. Come on, rewind enough. You only get so much rewind. It worked. Okay. So okay. So with this problem now, does everyone see the change I made to it? It is known that 20% of the heaters fail. What is 20% in this problem now? It is known that 20% of the heaters fail. So what's 20%? What is 20%? It is known that 20% of the heaters fail. It is known. That is P. So you can identify notation to start or just make sure you're doing it properly. I want you to figure out if it's categorical quantitative. Because once you find P, what do you find like this? Good job to Marcus. Once you find P, you instantly find what? You find P, you find what? So we would say the true proportion of failed heaters is equal to 20%. And you find Q. And Q, I did probability. You can write it that way too. The probability of success, the probability of failure. So now let me ask you this. Do we pass the 10% condition? Do we pass the 10% condition? So yes or no, do we pass the 10% condition and why? To check the 10% condition, one, what is n? Two, what is lowercase n? What is n? Oh, is n divided by? All right. Ooh, no way. Ooh. How many people have answered? I'm going to give 5, 4, 3, 2, 1. Oh, it's all right. How many people answered? Please be. I see we're losing people. That's all right, though. I'm very happy and very proud that 13. If you got it wrong, don't worry. But I think Jude put it in the chat that our sample of 100, because we took a sample of 100 out of the 1,000 heaters, 10,000 heaters, and that's less than 10%. That's 1%. So you would do 100 divided by 10,000 equals 0.01, which is less than 10%. So good work right there. How about the success failure condition? So we passed because it's less than 10%. Our sample of 100 is less than 10%. So now, to check success failure, what is P, what is Q, R, and what is N? What is N? Really? What is N? Are NP and NQ both greater than or equal to 10? It will never do exactly. So who has this one? Yes or no? Do we pass success failure? There are test questions just like this. Do we pass success failure? What do you think? And why? So you have to identify. Well, we know what P and Q are. We already did that. Notation.
Notation, brother.
And why? Well, why or why not? Why or why not? Go here, and P is this. Yeah, exactly. And then you can instantly figure out the failures because it's going to be 80 failures. So, yeah, that's how you do it. There you go. Jude has it in the chat right there. There's at least 10 successes, at least 10 failures. There's 20 expected successes and 80 expected failures. Exactly. So make sure you know these steps. And then it's only for categorical. The quantitative is large enough N. So just have that down, those practice right there, those steps right there to do it. I really think breaking things down into steps makes it a lot easier. Like do these steps and then put the steps on like a note card and practice right there, the steps. Okay, we're almost done. We're getting closer to the end of the Kahoot. Or over halfway done. Zany Nightingale, Shimmering Panda, Vivid Griffin. Isn't it still quantitative though? Not for a yes/no question because did the heater break or not break? Now the distribution is quantitative because it's the distribution of the sample proportion, which is technically like quantitative in nature because it's a probability. But the question itself, which makes it, is categorical in nature. Good question is Charlie right there. Because the question is, did the heater last 5 years? Okay. Large enough N states what? Large enough N states what? Which is for quantitative data. There's the numbers we mentioned, 1, 25, 100, and 1 is for normal data, 25 is for skewed data, and 100 is for heavily skewed data. When does N need to be larger? We saw this earlier just a moment ago. When does N need to be larger? To pass the large enough N, you need a much larger N when the distribution is what? Be very careful. There we go. The larger the sample needs to be. So if you selected this one, it would be the larger the sample, not the population needs to be. When the distribution is more skewed, less normal, the sample size needs to be larger, not the population size, which is large enough N is large enough sample size. So very good right there. Pretty good answers. There we go. Leaderboard. How do we check the 10% condition? You got this. This is a review now. How do we check the 10% condition? How do we do this? What does the 10% condition state? If I go on the screen, I'm usually not blocking the right answer. What does the 10% condition state? A lot of people get this reverse. Remember, it's the less than 10% condition. It deals with oversampling, and the equations don't work out right. There are ways to fix it in statistics. Great job, Peyton, right there. Peyton got a lot of points for that right there. We see if our sample size of n is less than 10% of the population. Success failures is its own thing. That's a different condition. Success failure is at least 10 successes, at least 10 failures. So if you're going towards success failure, you want there to be at least 10 successes, at least 10 failures. Be very careful. They both have 10 in it. And success failure, you want at least 10 successes, at least 10 failures. Watch this. If you go out and ask students, have they ever had a Pittsburgh steak? Apparently, only 2% of students, oh, this is not the output I wanted. Pittsburgh steak, really good steak to have. Cooked Pittsburgh, medium rare. Only 2% of students have had a Pittsburgh steak. If you talk to 50 students, how many of the 50 students would you expect to have had a Pittsburgh steak? So if you talk to 50 students, how many of the 50 students would you expect to have had a Pittsburgh steak? The probability is 2%, correct. I like that. That is true, 2%. But how many? The proportion or percent expected is 2%, but how many would you expect? So if there's 50 students, you'd expect how many of them? Close, Rylan. Not 0.2, but 0.02. So now we just times it by this right here, and that's the expected. And you expect 49 to not. So now watch this. Do we have at least 10 successes, at least 10 failures? No, we have 1 expected success and 49 expected failures. So with these numbers, guess what happens? The distribution looks what? The distribution looks what? Because we do not pass success failure, which is the reason we check conditions. We don't do it to see if we can calculate p hat. It looks skewed. But what if we're asking these 50 students, do you like Taco Bell? And 40% of students love Taco Bell, which is actually the question we're asking. So now we'd expect, is it going to be, I think it's 20 and 30. So here you go. How does that distribution look? Normal. Normal right there. So that distribution looks normal because there's at least 10 successes, at least 10 failures. Does that make sense? So if you have at least 10 successes, at least 10 failures, the distribution will look normal. But if you don't have at least 10 successes, at least 10 failures, it doesn't look normal. And that's when we can't use the central limit theorem. This is the binomial distribution, which is tangential to what we're learning, but the rules do still apply. Leaderboard, Zany Nightingale, Shimmering Panda, and Vivid Griffin. Next question. How do we check the success failure condition? You got this. This is review. I love review. You need to find these things. You need to find N. You need to find P. You need to find Q. How do we do it? This down here on the bottom, see if the sample size is large enough. This is the large enough N condition right here for quantitative data. We look at the shape of the data. Is it normal, skewed, or very skewed? And then depending on how skewed it is, we need a larger N. So success failure relates to successes and failures, but it's greater than. Want there to be at least 10 successes, at least 10 failures. Yeah, I like that. Wow. That's good stuff right there. Is this going to get posted? Oh, yeah. Always posted. Thank you, Peyton, for being here. I know we go a little bit long, but this is posted right after, just like class. Here we go with the next question. Leaderboard. Zany Nightingale, Shimmering Panda. Remember, there are points. We'll do top 2 today. Get Starbucks or Amazon. Please email me if you're the top 2, Starbucks or Amazon. $20 Starbucks or $20 Amazon. Email me. And if you don't get it, let me know. And I do usually take these things back after 1 year because I did this for like 3-4 years. And then I looked and there was like a couple $100 of unredeemed. Now there was like almost $1,000 of redeemed. But I was like, wait a minute. Been doing this for quite a while and people aren't redeeming it. So yeah, recommend reviewing this Kahoot again closer to the exam. Thank you, Sarah, so much. Yes, and make sure when you go in, when I send you the Amazon gift card, just redeem it right away. But then this allows me to give out more even if someone doesn't redeem it. Because if you go 2 years and don't redeem it, I usually wait about a year. Each year, at the end of this year, I go back to the 2024s and go through and if someone hasn't redeemed it. I'm like, you had a year. I think you forgot about this. Here we go. Next question. The success failure condition states which of the following? What does it state? And I put this one on here for a reason because it's on the Canvas content. It does not state your data needs to be binary. I mean, you could say, well, isn't our data binary? That's not what the condition states, though. It might require binary data. Good luck, Peyton. Thank you so much. It might require binary data, but it doesn't. That's not the condition. What does it state? And I might be blocking the answer. I think I am. I try not to. Exactly. Why wait to redeem a gift? Yeah, Logan knows. It does not state it needs to be binary. And true or false in the chat right now. You need to check conditions to calculate p hat or y bar. Yes or no in the chat. You need to check conditions to calculate p hat or y bar. I know, Peyton. I think I had what got me was like I had $100 one I sent to a student and like it was 2 years and they didn't redeem it because my wife was like, you can't be given $100. It was like big Kahoot $100. So I've tried to keep it towards 20. But then like they didn't redeem it and I was like, that's $100 that just went to Amazon. And Kira knows right there. We don't check conditions to calculate p hat and y bar because do this. What's the average of 5 and 7? What's the average of 5 and 7? Just type it in the chat. Or what's the average of 6 and 7? 6. So, or 6.5 if we do the other one. So, you kids and your memes. Did you check any conditions? Did you check any conditions? Just right now in your head, did you check any conditions? To be like, how do I average these numbers? If 3 of your friends out of 10 own cats, what % of your friends own cats? If 3 out of your 10 friends own cats, what % of your friends own cats? If 3 out of your 10 friends, you're about to calculate p hat. 3 is x, 10 is n, 30%. Did you check conditions? No. You check conditions and see if it passes to see if the data is normally distributed. So remember that, especially for the exam. You don't check conditions to calculate p hat and y bar. You check it to model the distribution of p hat and y bar. So the calculation of p hat and y bar is just averaging, or p hat's also kind of an average, like on average 30%. I mean, yeah, it's categorical. Okay, Zany Nightingale, Shimmering Panda, Glowing Goat. Next question. Probability of making a shot is 30%. What's the complement? If this is P, what is Q? Should know how to get P and Q pretty quickly. We're on the home stretch on the Kahoot. I got my sandwich today. I got my shin ramen over there. Thank you so much. Check out, I hope the festival's still going on. I don't know what time it goes till, but it was so great seeing a lot of students. I had $20 a day and I spent it like that. It was like money gone. So many good. The pancake was the best. Shin ramen's good too. Boom. We do pretty good on this one. How are people feeling? Get a little poll in the chat here. I'll poll for you, Sarah, right here. Start a poll. How are you feeling? Okay. Good. Mid. Oh, wait. No, we're taking away mid. Amazing. Good. Bad. We're doing a forced choice scale. Okay. How are you feeling about the exam? This is a very, very... could use some more practice, Peyton. I agree. Practice makes better. Next question. Leaderboards, Amy Nightingale, Glowing Goat. Here we go with the leaderboard, or the question. The law of averages is a fallacy. The truth is what? Oh, no. The truth is what? Now, there are other truths on here, but the law of averages is when someone's playing at a casino and they keep losing, and they're like, I'm due for a win. That's the law of averages, which is not true. It's known as gambler's fallacy. Which isn't exhaustive. Dude, right there. Are you like the review? Oh. What are you wondering about, Jude? We've done a lot. There are things we didn't cover. It's really hard to cover it all. The law of large numbers. I kind of hone in on a few things right here. Oh, the poll. Thank you, Jude, right there. I was like, oh, no. Yeah, that's just a joke. It is. You're right. It's not exhaustive of all the things right there. I know you want a mid option. All right. Oh, wait. Here we go. Here we go. Watch this. It's going to be like 80% are feeling mid. Everyone wants a mid option. It's, yeah. When you do polling, if you do a forced choice, it makes people lean in one direction. But if you don't do a forced choice, people then generally a lot of times choose the mid option. So you get all this like centralization towards the middle, and everyone's kind of like meh. And you'd be surprised. People don't usually have strong opinions on all that stuff. I think there's like the 1 or 2 issues people care about, and then the rest are like, whatever. To calculate p hat, we must meet the 3 conditions. Review question. Almost like this is on the test, and I want you to know how to answer it. You got it, Peyton. Don't worry, Peyton. Peyton, I'm throwing you 10,000 points here, and I want to say this. This is a review question now, so make sure to do it right. Peyton, I didn't know about test anxiety till I took a really hard math class, and I'm good at math. And I sat down for that test, and it was like everything fell out of my head. So I'm there with you. And I will say this. This is one of those classes where if you do all the work and you show up and you do the Kahoots we do in class, you show up, I can't promise you'll make an A or B. And I'm not saying you'll just make an A or B. But a lot of students make at least a B in the class. So it's not the easiest class. Exactly, Sarah. It's like there's some tough classes. This is not the easiest class in the world. You put me in an English class, I'll be happy to make a B. Exactly. Practice makes better. So the best thing we can do to set ourselves up for success is to study with good technique, Podomoro method, and then also to do all the work we can that's outside of the test, because we can then like do my Pearson multiple times. We can double check our work. We come to office hours. A lot of ways that we can make sure we have the highest grade going into the test, and then que sera, sera. What will be, will be. So yeah, and then we say, man, I give my best effort. Go forward with no regrets. Here we go with the leaderboard. Zany Nightingale, Shimmering Panda, and Glowing Goat. Only a few more questions to go. We know UT is 20% freshman. We sampled 200 students and 30 report being a freshman. What is P? This goes back to review. Hadley was asking for that review sheet. Good to see Hadley still here. What is P in this problem? So a lot of these questions for sampling distribution boil down to knowing your notation. What is P? Oh, why was the last one no? Because to calculate P hat, you simply just do 3 over 10. 3 of your friends own cats out of 10. 3 over 10. No conditions are checked to calculate P hat. It's just the proportion of a sample. So what is P? Ooh. Well, I'll ask, but I think we know. What is P? What does P mean? Nice job. Thank you, Peyton, right there helping out. What does P mean? Like, what is P? What is P? The true proportion. So we know UT is 20% freshman. We're throwing, everyone here gets 10,000 points. My favorite thing is students helping students. Thank you so much right there, Peyton. Top tier answer right there. P has just a calculation based on data. The conditions are checked to make sure we have a normal distribution. Breathing exercise like box breathing. Oh yeah, like you go. Is that box breathing? I feel like I'm trying to like enter the matrix or something. So, and Kira pointed out 30 is X. So what is P hat? DeMarcus got some really good advice too. And then Ashna asked, what is 30? And 30 is X, the amount of successes. So what is P hat for this problem? Because this problem is going to get used again. P hat is, well, what is P hat though? P hat's the sample proportion. P is 0.2. P is 0.2. P hat is 0.15. Great job, Wilson, right there. P hat is 0.15. So X over N equals P hat. Because it's 30 divided by 200. Yeah. So the amount of successes over the number of trials is the sample proportion. And what is, I might be asking, what is mu y bar? So, or mu p hat. Oh, I can't even think. What is mu p hat? What is mu p hat for this problem? What is mu p hat for this problem? So mu p hat equals p. Yep, that's right, Kira. Because mu p hat equals p. So what does that mean? If you go out and talk to students, you'd expect 20%. Yeah, don't worry. There's a lot of little notation and just reviewing it, things like that. Like mu p hat is the expected sample proportion, and we expect the sample proportion to be the true proportion. It's a little confusing, but good time to review. Okay, so let's look at the leaderboard. I want to know who wins this. The expected sample proportion, right? Jude, right there, when we take a sample. Zany Nightingale, Shimmering Panda, Vivid Griffin. Next questions. UT is 20% juniors. From 80 students, 30 are juniors. Find the mean of the sampling distribution. Find the mean of the sampling distribution. It's almost like it's a review question. What is the mean of the sampling distribution? Take a look at the pinned comment. Find the mean of the sampling distribution. Like I said, most people feel mid. All you had to find in this problem was what? All you have to find in this problem is what? Pretty good. Yes, DeMarcus. Great job, DeMarcus. Excellent, DeMarcus. Glad you're here. All you had to find was P because mu P hat equals P. So UT is 20. And I'm stating it as a fact. It's not from a sample. It's like UT is 20% juniors for some reason. Oh, that's all right, Sarah. I think Sarah won. Sarah came in second. We had like 60 or 70 people play the last one. And it's a speed game then because Sarah's going to get them all correct. And then I think second, right? DeMarcus, send me an email real quick from your UTK email address and say, because Kira, if you know DeMarcus too, I want to mod people, but it's always like anyone can join from the random web from any class anywhere. DeMarcus, if you send me an email or Hadley too, I will mod you. Send me from your UTK email address and like a screenshot and be like, hey Brian, it's me from your UTK email address and I will mod you. So Kira, thank you for asking. I'm always afraid because a quick story, I got second last time, 8th grade. That's all right. But I'm so glad people are here and joining in. That's why classes are unlisted. So people can't find our class randomly on the web, but they can see these videos. These videos are public to the web. Also not monetized too, just public to the web videos. So in our class is never monetized unless I mess. The last time class got monetized, I put a Watsky video in and I played 10 seconds of it and I got hit by Universal or something. They're like, oh, we're gonna put ads on your class. Here we go with the next question. Thank you, Peyton, right there. Zany Nightingale, Glowing Goat, and Shimmering Panda. We know UT is 20% freshmen. We sample 200 students. 30 report being freshmen. What is P hat? Have to know that notation. I think we got this though. I didn't even drop my email. It's bstevens@ut.edu. I have 42 emails. So for this one, P hat is X over N. X is 30, N is 200. P hat is 0.15. I love review questions. Okay, it's the last question. It's the final question. Here we go. Zany Nightingale, Glowing Goat, Shimmering Panda, Vivid Griffin, and Honest Rabbit. Rabbit, you got... I don't think you can win technically, but I'm glad to see you here. Here we go with the last question. It is... UT is 20% junior, and we sample 80 students, 30 are juniors. Find the standard deviation. So how are you going to find the standard deviation of the distribution? This is all categorical. So to find the standard deviation of the distribution, we have to go in, and we have to do standard deviation of the sample proportion is equal to P times Q over N square root. So this is going to be P. This is going to be Q, and this is N right here. And then we plug in the numbers. And that'll be the, no, wait. Oh, it is 80. That'll be the answer. It's got to be a smaller decimal. It's probably going to be, it's one of these two on the bottom. I'm going with this one. Yeah, I said at the last second. How do we do? Oh, wow. Wow. Oh, wow. I know we're down to just the people here staying to the last end of it. I'll stay and answer a few more questions, but let's go look at the Kahoot Island. Here we are with the podium. Remember, if you're the top two, and once again, Sarah dropping her information in the chat, check out Sarah's information. Also, if you're seeing this in the future, Sarah's dropped her information right there onto email. Once again, great tutor. You got kicked by my going to my calculator. No. Oh, you did? No. You're Zany Nightingale. Nice. Kira. That's amazing. Amazing job, Kira, right there. We even got some prizes, apparently. Who came in second? Who is Glowing Goat? Great job, Kira. Great work. So we'll find out who is second. Anyone want to say who second is? Reptar, good to have you here. I was sixth. Still great work, dude. And this is a tough competition. Got randomized? Nice. Oh, no. If you got second, right? Then randomized, you're in. I can't. I guess I modded randomized. I need. Please email me. Let me see. Did they email me yet? Oh, wait. Yep, found him. Here, wait. DeMarcus. DeMarcus, you're good to go. And here we go. And I need to join people into the Discord. And then Hadley. Where's Hadley? There we go. Boom. We got both right there. And then I'm going to add some people to the Discord. Let me go to the main screen. Okay, DeMarcus, thank you for being here. You got it, DeMarcus. Thank you so much. Really glad people are here. You're welcome. And thank you for everyone for being here. I'm going to get some people added to the Discord bot's been down lately. And I got such a headache when it... let me, okay, auth. There we go. I see. And Hadley, you are in. You're good to go, Hadley. I'm having to manually add people, but Hadley, you're good to go. I might try to get the Discord bot working again. At the start of the semester, it just crashes randomly. Gosh, how do I do it? I need to make a video of myself doing it. On the last question, why would you use 0.2 and 0.8 instead of the sample? That would be the standard error, Peyton. Good question. If you did that, you're welcome, Hadley. And if anyone else needs help, please let me know, especially when you email from your UTK and you're like, hey, Brian, I'm trying to get in the Discord and it won't work. Then I'll do it. I'll fix it up. Business bot needs to come back. Yeah, let me try to fix that, Sarah. I'm going to fix that here. Probably, I might do it offline, but I know, right? It's been down for like a month and a half. At the start of the semester, I like make sure it's up, but then I have to contact like OIT and I'm like, how do I get on there again? And they're like, Brian, we tell you every time how to fix your bot. And I'm like, I forget. Because it used to be one way. And then we no longer have access to that. And they changed the process. And I was so used to the one way. Yeah. Does that make sense, Peyton? If you use the p hat, which probably the other one is, it'll be the standard error. But the standard deviation is p times q over n square root. The standard error is p hat times q hat over n square root. So the question asks, what is the standard error, which we'll be using later on. If we don't have p, we usually use p hat, the standard error, which is more confidence interval calculations. Because in a confidence interval, you don't know the truth. So that's got it. Correct. The chapters kind of show you it a little bit. It won't really be on this test. Yes, huge out. Thank you so much, Sarah. And once again, anything you do on the Discord, I am so honored by. Sarah catches spammers and scammers on our Discord every once in a while and bans them immediately. I'm usually like in class or something, and Sarah's like, I found this person doing this thing. Like, they'll post usually to the auth channel or somewhere, or to the mod help or somewhere, and be like, check out my Discord server where you can get Taylor Swift tickets and tutoring. And then it's like, ban. It's like, you're gone. And be very careful if you see random links. Don't click them. And if you see anything on the Discord you think shouldn't be there, or someone acting out of the volunteer spirit, let us know right away. We've really had next to no problems. Like, every problems we've had on the Discord have been so minimum. And we've caught them very quickly. And if you do something with online stuff, you're going to have issues. But due to our security on how you have to get in, we keep it pretty like down to just UT students. And then once again, if anything's ever happening, let us know. Let mods know. We will address it as quickly as possible. I'm very proud of the Discord. I was a little worried when we first started doing it. I was like, nah, we got this. And then we set up the security. Thank you to Dylan Skonecki and Dennis. I can't think of Dennis's last name. It starts with an R, I think. I'll message him on Discord. Thank you so much, Randomized. It's very vol of me to sell. No, you can't do that, Logan. Logan, I'm going to start working out again, I think. I got out of it, man. Like, I'm hoping my Deadpool costume fit. Not that I have a Deadpool costume.
Hi, everyone. Deadpool here. Just wanted to say happy Halloween, go balls, and maximum effort for test 3.
Not that, yeah. I think it actually looks better than that video. Like, it's really good material. Got it ordered. It's like a little bit of money. Had to do like all the sizing and stuff. And so, but worked out really consistently, and then I keep telling people I hurt my tendons. Do you have a membership to a gym? With me being such a, I assume a gym, right? With me being such a germaphobe, I used to go to gyms and just like whatever, work out and everything. Now I'm just like someone's like, I didn't wipe my sweat off the machine. I'm like, I don't care. Now I'm like, oh, they had one drop of sweat hit that machine. Ah, too much of a germaphobe for gyms. I've lost it, man. COVID did a number on all of us, right? I know, right, Kira? I think COVID impacted all of us in different ways. I was in 3 years, I was in Texas, and just like the only person I really saw was my wife. And because of that, it caused a lot of like some social anxieties that I didn't have beforehand. And so like even today I was at an event and I was sitting there and some people around me were kind of coughing a little bit. Not like much, not like major, not like, what are you doing here? I mean, you know what I mean? Like if someone's like, bleh, you're like, what? maybe you should go home. But it was just light coughing and I had to move around seats just because my anxiety started to kick in too much and I was getting too and I know those things about me. And I was like, it's not like, I'll be fine or whatever, but like my brain rationalizes that. The cleanest gyms in Knoxville has to be Planet Fitness, but in benchmarking with other gyms in that area, oh, cool, Planet Fitness? Yeah. People make fun of Planet Fitness, but I've actually heard good things. Like, there's like the old school gyms where it's just a bunch of like tires and like weights on like, just free weights and everything and like ropes and like bars sticking out from walls to do pull-ups on. But I bet Planet Fitness has pretty good clean gyms. And it's just like, man, I'll just, if anything ever happened to me and I was like at the gym and I would have way too much anxiety. And I've been, I was really consistent. I bought a lot of weights. I got up to curling. I was curling with 35s. So they just don't have the lunk alarm. Like, it's a go to gym, cheap, and membership allows you to go to any in the country. I bet. I was working out with 35s. I was doing like overhead presses with 35s. My form was probably so trash. Like, shoulder presses with 35s. Like, I'm gonna hit everything. Like, it's a good shoulder press. Maybe you're supposed to have your elbows up. Shoulder, like, I don't know. It's probably working up here. But like 35s, trying to keep those elbows flat. And yeah, like I was doing everything with 35s, and then I just started to get pain across like the tendons in your arms that go like with here to here. I had like tons of pain and I couldn't extend my arm all the way out. It's like golfer's elbow or tennis elbow. And I was doing around 50 pull-ups a day, but not in a row, obviously. And DeMarcus, fitness goat right there. Oh, DeMarcus is really good at it. Oh, there you go. And I was just like, I was so morbid in on it. I was like, I'm going to be in perfect shape. And then my wife, like, one night I'm going to bed and I was like, ow, ow. And she was like, what's wrong? I was like, my elbow hurts. And she was like, how's it hurt? Reverse curls? Let me look at this. Reverse curls. I should do that. Maybe I do some. Let me look at reverse curls. Thank you for give me advice on this. Reverse curls tutorial. And then also I need to get some supination, pronation. Oh, a bar. Okay, actually, that's Buff Dudes. I've watched Buff Dudes before. So I'm watching Buff Dudes right now on a reverse curl. God, those dudes are jacked. And then Jeff Nippard's on here right now. So he's showing kind of the form for it. Oh, I've done reverse curls. You're talking, okay, so reverse curl, you have the bar and then you go like this. So reverse curl, so the grip, and then you do that. I can feel it. I can actually feel when I do that. I can feel it across here. Yeah. So, an open book to Marcus. I need to figure out the problem is I was doing around 150 push-ups a day too. And I think that also caused, basically I got a stress-induced injury. Like doing 150 push-ups and 50 pull-ups. Of course, these were increasing when I started working out. I was doing like 10 to 15 to 20 pull-ups or something like that. And then I was doing like 60 push-ups and I got up to doing like 150. I was doing sets of like 30 or 40 push-ups. Like I was doing a drop set, like 40, 35, 30. And like, I just remember like, I'd be doing like 38, 39. And I'm just like, ah. And that really like for like shoulders and everything like that, like shoulders and lats is more pull-ups. Anyways, I should put in reverse curls. He's just showing like all the veins in his arm right now. He's like, yes. Yeah, he just pointed. I'm not even kidding. He just pointed to the tendon that's giving me problem. He's showing, yeah, I can show you. But he's literally showing right now exactly. Seeing that gives me confidence. Don't hit us with a copyright claim buff, dudes. He was literally where he's touching is where I feel pain. That's where I felt pain, like to the T is right there. So that's, thank you for that. Any other last suggestions? I probably need to start putting reverse curls into my routine. Maybe do them, what, 2 to 3 times a week? Like if I do 6 workouts a week, I could do every other day doing reverse curls. Like not do it every day and do like sets, supersets. It's supersets where you do like, you move from one thing to the next, right? Superset exercises with heavy farmer carries. I like farmer carries, but I don't have heavy enough weights for them. And also I bashed my finger. Check out last year's, I'll show you one last thing here. So last semester, I bashed my finger doing chest flies. I was doing chest flies, and it's not when I put the weights together, I didn't do that. I actually brought the weights down to the side, and then I smashed my finger. Supersets with heavy farmer carries. I love farmer carries. Like, that's really good for balance. So, but I only have the 35s are my biggest weights. Okay, so here's last semester when I was in better shape. And I'm pretty sure I've bashed my finger at this point. Okay, so let's go here. Exam 2. This is exam 2 last semester. And then we'll end. Yeah, it was a bummer. See, I think I look a little thinner, a little better. Like, and then there it is. Actually, you can see the finger right there. Anyone see that? Maybe see it from the start. I don't know if I hold my hand up. Actually got more black, I think, because it... Not like I hold my hand up a whole bunch. Bash my hand good. It's that, there you go, right there. It's a subungular hematoma. You see the finger. It was on my wet... There it is. Wait, I'm going to pause it when I put my hand down. That, right. Really, there it is. There's the subungular hematoma. So, anyways. What is a subungular hematoma? Bash my finger. I saw a veterinarian that night and took off my wedding ring. So, I appreciate all the good advice right here. They should be supersets. What type of physical therapy does Brian need? I actually had to do physical therapy for my hip because I needed they told me I might need a hip replacement. You gotta be careful. You can hurt your body so many ways, but the hip stuff is due to what is it? Hip impingement. The ball joint of my hip is misshapen, so your ball joint is supposed to look like that, and my ball joint looks like this, which causes hip impingement and causes inflammation and arthritis and pain. They're like, we could do a hip replacement on you, and I was like, how about no? How about no? With that, Sarah, I'm going to try to get the business bot working. Thank you, everyone, for hanging out. I appreciate it. Sometimes you just need to chill right here and just relax. DeMarcus, nice meeting you. Glad to have you as a mod. Good luck on the test, everyone. We're going to get the business bot, or try to get the business bot working. And then I'm going to go home, mow the lawn, and get ready for the test. Bye for now, everyone. Bye. Thank you, DeMarcus. Bye.